I'm here with our NS MiniTracer, which is our smallest, most compact, and most sensitive near-infrared fluorescence instrument. It's composed of 3 parts: our main optical unit, a near-infrared spectrometer, and then a laptop computer, which is used for acquisition and control. Now, the main optical unit houses a single excitation source. It's either a 640 nanometer or a 785 nanometer laser. The 640 nanometers is excellent for single-wall carbon nanotube samples, and the 785 has been very desirable for people working on near-infrared medical imaging dyes. This particular unit also has the option to do near-infrared absorption in addition to near-infrared fluorescence. So it also houses a tungsten lamp. We can detect near-infrared, both the absorption and the emission, from around 900 nanometers to 1600 nanometers. So I'm back with the MiniTracer. I now have everything connected to power and connected to the computer, and we're able to start it up and see how it works. So I'm just going to go ahead and open up the software program. And this program controls everything, so it'll power up both the main optical unit, and it will also start the power going to the near-infrared spectrometer. So when it starts up, it immediately takes just one trace of the background. At this point, we can go ahead and start using it if we're interested in it. So if you already know what your sample parameters are, or you just want to take a quick look, you can take a reference at the current settings, and then you're ready to start acquiring your near-infrared spectra. So I have here a sample of single-wall carbon nanotubes. It's incredibly dilute, looks just like water. Put it into the sample holder and take a spectrum. And just like that, we have a very nice single-wall carbon nanotube spectrum in 100 milliseconds with a single acquisition. Now, one of the nice things about this software is that you can acquire just continuously, and then if you want to rapidly check and see the difference between a couple of samples, you can just pop one out and pop the next one in. And as soon as you shut the door, the laser will be reactivated, and you'll get another nanotube fluorescence spectrum. And this would allow you to quickly check between different compositions of different samples, or get a rough estimate of the fluorescence intensity of different samples. So this is a sorted sample, so it only has a single type of nanotube species in it, or just a couple. So this software also comes with an auto-acquire function. So I have here a HIPCO nanotube sample that is slightly gray. I can hit auto-acquire. It'll prompt me to enter the sample. And I'll run through a bunch of integration and averages that allows you to maximize the signal to noise for the fluorescence intensity of this particular sample. And once it figures out the right parameters, I'll prompt you put in your reference. And the result is you have incredibly nice signal to noise on a single wall carbon nanotube fluorescence spectrum. Now, this system also has the ability to take absorption spectra. So let's switch over to absorption. In this case, it'll be the reverse. When you go to auto-acquire, it will ask you for your reference first. It will set the integration and averaging time based on the intensity of the lamp. And then we insert our sample and acquire the absorption spectrum. So you can see we got some pretty nice peaks off of this sample. Now, water absorbs very, very strongly out past 1400 nanometers, and that's what all the light from the lamp is being absorbed in this region out here, and that's why it just looks very noisy. But we have some very nice single-wall carbon nanotube peaks in this window where we don't have the water absorption. So we also have a sequence mode, which will use your current reference that you have done in individual mode and allow you to take just a series of fluorescence spectra over a period of time. We have a calibration curve function. This allows us to put in a set of standards in order to measure the fluorescence intensity off those standards, and then go back and put in our unknown and calculate the concentration based off of those, based off of the calibration curve. And then when you've finished with all your samples, you just go ahead and start. And then you can press show dependence, and that will give you your calibration curve. Done. So now, since I've applied the calibration curve, when I take this spectrum of this sample, which I set as 1, my total integral now gives me a value of 1. Now when you're finished with a MiniTracer, it's very simple to shut down. Just go ahead and take your samples out so you don't forget them, and then just exit the software. The software will close out, and it'll also power down the unit and the near-infrared spectrometer. Once it's powered down, it's fine just to leave until you're ready to go and use it again, and all you have to do is go back and open up the software, and everything will start right back up again.